Sans Maths channel. I'm now answering question number 3 from the May-June 2023 Mechanics M1 paper. This is paper 4, variant 2. This is from the 9709 syllabus. Here we have a diagram which shows coplanar forces of magnitude 30 newtons, 15 newtons, 33 newtons and p newtons, which are acting on a point in the direction shown in the diagram, where the tan of alpha is equal to 4/3. The system is in equilibrium. So these forces are in equilibrium. So we got to show that 14.4/30 minus p squared plus 28.8/p plus 30 all squared equals 1. Now it looks really kind of a bit complicated when you look at it like this, but let's just make a start and do what we know we have to do. Even though this looks all complicated, in the end things should clear up, and don't get scared by the way it looks in the beginning. In fact, it's actually quite easy, as you'll see. Okay, just a bit of manipulation involved. So the first thing we're going to do is we're going to do as we normally do in this kind of situation, resolve the forces horizontally and vertically. So that's what I'm going to do. I've just made a diagram down here so that I can refer to it easily. So I'm going to resolve these forces horizontally and vertically. Okay, so I'll just use a different color for the resolving. So for example, I'm going to resolve this 15 newtons force in this direction and the 30 newtons force in this direction as well. The 50 newtons force in this direction and the 33 newtons force in this direction as well. The p newtons force in this direction and the 33 newtons force in this direction also, and the p in this direction and the 30 also in this direction. So I'm going to resolve the forces in those directions, and then I'm going to look at the horizontal and vertical components summed together. Okay, so I know, for example, here I have 15 and here I have alpha. If I want to resolve this force in the direction going into the angle, I have to go into the angle. I'm going to use cosine. It's like I'm finding the adjacent side. So this would be 15 cosine alpha. And in this direction, I'm going away from the angle. It's going to be 15 sine alpha. Okay, 15 sine alpha. And for this 33 newtons, if I resolve it horizontally, I have to go into the angle. So again, I'll use cosine. So 33 cosine alpha. And in this direction, I'm going to go away from the angle given. It's like I'm looking for the opposite side. So it's going to be sine. So 33 sine alpha. And then I'm going to resolve the forces on this 30 newtons and this p newtons. Now, if I resolve it horizontally, this is going into the angle. So this will be 30 times going into the angle cosine theta. And this will be p times, again, cosine theta. And vertically, I'm going away from the angle. So in this direction over here, it's going to be 30 times away from the angle sine of theta. And down here, this is going to be p times sine of theta. So I've resolved the forces horizontally and vertically now. So now what I'm going to do is I know that it's in equilibrium. So I know the forces acting to the right and the left must balance out. So to the right, I have 15 cosine alpha plus 33 cosine alpha is equal to 30 cosine theta plus p cosine theta. Okay, so that's from the horizontal. And what I'm going to do, I'll leave a bit of space for me to work. And I'm going to also show the vertical components. I'll do this down here. So the vertical components, I have here 30 sine theta plus 15 sine alpha. So 30 sine theta plus 15 sine alpha, and down equals p sine theta plus 33 sine alpha. So now I'm going to try to simplify these. Now what I know, as I told us, is that tan theta equals 4/3. Or tan alpha equals 4/3. So we can work out what sine and cosine of alpha is in the exact values. And it's always best to use the exact values, especially in this type of situation. So what we're going to do is, we know if tan of alpha is 4/3, we can draw a triangle like this. If this is alpha, the opposite is 4 and the adjacent will be 3. So the hypotenuse is going to be 5 because of Pythagoras' theorem. So we can say now that the sine of alpha is opposite, which is 4 over 5. Okay, and the cosine of alpha is adjacent over hypotenuse, which is 3 over 5. So in here, I can replace the cosine alphas with 3 over 5 and the sine, or there's only cosine alphas here, this first one. So I can replace them both with 3 over 5. So this is going to be 15 times 3 over 5 plus 33 times 3 over 5 equals, I can't do anything with this yet, so I'll leave it as 30 cosine theta plus p sine theta. So this cancels with that, leaving you with 3. That's 9 plus 33. I'll just put this in the calculator and put the answer. I can find out what that is. That's going to be 15 times 0.6, which is 3 over 5, plus 33 times 0.6. That gives you 144 over 5, which is 28.8. 28.8 looks promising. There's a 28.8 there, so it kind of looks like we're on the right tracks here, which is good, and equals this. Now, I can see something here that will help us from now. I can see what the situation here is now because I see there's 30 cosine theta plus p sine theta, and I see there's a 30 and a p together added like this, 30 plus p plus 30. So I could take out sine theta as, this is cosine, this is supposed to be cosine theta. What am I doing? Be careful. I messed up there. That's a cosine theta there, see? So I can see cosine theta is a common factor, and I've got 30 plus p. I can write it as p plus 30, so it matches that. Cosine theta is common, you've got p plus 30 inside the bracket. So from this I can say cosine theta is going to be 28.8 over p plus 30. So I can see I've got this now. And I can see what this comes from, the identity sine squared theta plus cosine squared theta equals 1. All right, so that means I should be able to, from the vertical components, come up with, I'll just come up with sine theta equals this, 14.4 over 30 minus p. Let's see if that works out. So we got sine theta is on opposite sides. Let's bring them together. So you have 30 sine theta minus p sine theta equals 33 sine alpha minus 15 sine alpha. All right. So I know what sine alpha is. Okay, sine alpha is, I think it was 4 over 5, right? Yes, 4 over 5. Which is 0.8. So I can again see that sine theta is common. In this case, sine theta is common. And I've got 30 minus p, which looks promising again. 30 minus p. So this must give you 14.4. If I do 33 times 0.8 minus 15 times 0.8, hopefully that gives us what we need. We have to show the calculation, otherwise we will definitely lose marks. Because this question does tell us to show that, and they give you exactly what you have to show. So that's why you have to make sure you do, show your steps here. So I'm going to write 33.0.8, 33 times 0.8 minus 15 times 0.8, and that gives us 72 over 5, which is 14.4. So this gives us 14.4. And this is the sine of theta times 30 minus p. So I can now say that the sine of theta is equal to 14.4 over 30 minus p. 30 minus p. And now what I can do is I can combine these two together. Okay, if I know that the sine of theta is equals 14.4 over 30 minus p, I can use the fact that the sine squared of theta plus the cosine squared of theta equals 1. Remember, this means sine theta squared plus cosine theta squared equals 1. That's what it means, remember? So now I can take my sine theta and I can put it in the bracket and write it as squared. You don't have to actually square it because it just leaves it in this form. Plus, and what I got for cosine theta, which is 28.8 over p plus 30. 28.8 over p plus 30 squared equals 1. So that's exactly what we have to show. 14.4 over 30 minus p squared plus 28.8 over p plus 30 squared equals 1. And there we have the answer as required. So this question was a bit of a manipulation involved, but once we got to this, I realized exactly what we have to do. This is basically using the identity sine squared theta plus cosine squared theta equals 1. Okay, so that's the answer to part A. Okay, now for part B, it says verify that p equals 6 satisfies this equation and find the value of theta. Okay, so now if p equals 6, then let's see what happens here. You have 14.4 over 30 minus 6 squared plus 28.8 over 6 plus 30 squared. Now this should equal 1. So you have 14.4 over 24, and that should be squared, plus 28.8 over 36, and that should be squared. So let's try to work out what this actually gives us. We have 14.4 over 24. If you square that, that gives you 9 over 25. Write the steps out a bit in detail here because it's a show that type of question. All right, and then you have 28.8 over 36, close bracket squared, and that should be 16 over 25, and it is good. 16 over 25, which is equal to 25 over 25, which is equal to 1. So therefore, p equals 6 does satisfy the equation. Then it says, and find the value of theta. So what we can do is, we can use p equals 6 and one of those ratios. For example, I could use cosine theta equals 28.8 over p plus 30. So I can say cosine theta equals p plus, which was, what was it? Sorry, I forgot. Cosine theta was 28.8, sorry. 28.8 over p plus 30. 28.8 over p plus 30. So therefore we can say cosine of theta is equal to 28.8 over 36 because p equals 6. So theta is the inverse cosine of 28.8 over 36. Okay, so we can take our calculator and make sure that we are in degree mode. They didn't tell us the angle. Well, we can use it in degrees. So we're going to have inverse cosine of, in brackets, 28.8 over 36. Close the bracket, and that equals 36.89. So theta is equal to 36.89. That was 869, 36.869. So as we should always do, we should round to one decimal place if it's an angle. So 36.9 degrees. And that concludes this question. That's part B. Is there a part C? I don't think so. No. So that is the end of this question here. Question number 10 from, no, sorry, not 10. Question number 3 from the May-June 2023, paper 4, variant 2, M1 paper. A lot of trigonometry in here, but it's all to do with resolving forces and not getting confused or scared by the way things are supposed to look. So there we have the answer to this question. Other questions from this particular paper can be found in the playlist that will appear in this region over here at the end of the video. You can link it to there. Other questions from this topic of statics in M1 can be found in this playlist over here. This will be my Cambridge stuff. You can also look at this playlist here, which will have statics from my Edexcel collection. And you can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.